Well, limits of composite functions can be tricky. So given the graph of f below, here's this piecewise function, find the limit as x approaches 0 of f of 1 minus x squared. Okay, so what this really is, and there are exceptions to this, but what this really is, well, this. This is essentially f of the limit as x approaches 0 of 1 minus x squared. And let's go back to what was written earlier. So this is this if f is continuous at the limit as x approaches c of g of x with some exceptions. And these are the exceptions. These are the crazy things that can take place. So first of all, let's figure out the limit as x approaches 0 of 1 minus x squared. And as we do that, we have, well, the limit x approaches 0 of 1 minus x squared. Can I plug a 0 directly in? Yes, I can. I end up with basically f of 1, okay? And then, let's go back. If f is continuous at the limit as x approaches c of g of x, in other words, if f is continuous at 1, is f continuous at 1? No. But this is one of the exceptions, okay? So this is not necessarily a true statement. So it's actually not equal to this. So sorry. But here's what we do want to talk about. And the direction from which you come to figure out the limit has everything to do with how you do this. Okay, remember when you're finding the limit, you would say, oh, I'm approaching from the left and the right, and I got different answers. Okay, in this case, I'm only going to be approaching from one side, and here is why. So let's take a moment and draw a graph that you've seen a lot. 1 minus x squared is a parabola that is upside down and has a y-intercept of, well, 1, okay? If we wanted to find this, which we already found to be 1, right? We were like, oh, let's just use direct substitution. If I want to find the limit as x approaches 0 of this graph, then I would approach that and I would get a value of 1. But notice that as I'm sneaking up on a y value of 1, we're coming at it from underneath consistently. So we are coming at this 1, this y value of 1, from below. So the final answer to this is really what I get as we are approaching 1 from below. Okay, here's some notation here. Don't panic when I show you this. We're approaching 1, not negative 1, but we're approaching 1 from the left. We got the answer of 1 by approaching it from numbers that were less than the y value of 1. So now as we continue to evaluate, we're going to be figuring out what we get as we approach an x value of 1 from numbers a little bit less than 1. And that's what this little negative here is for. So that is going to apply there. So it's not the value of the function at 1. It's not even continuous. But because we got this 1 by consistently coming at the 1 from the same side, which was in this case underneath, we're going to find the limit as x approaches 1 from numbers less than 1. We'll call it limit from the left for f of x. And in that case, we do that and we get 2. Now again, don't be like, well, this is a 2 and this is a 3, and no. Otherwise, this graph would have looked differently. Okay, so final answer is 2. All right, if that didn't make sense, here's another one. Given the graph of f below, find the limit as x approaches 0 of f of x. So let's do this. This is really f of the limit as x approaches 0 of f of x. So let's find that first. The limit as x approaches 0 of f would be 2. As I did that, we approached the 2 consistently from underneath. If the graph would have come down like this, we would be approaching from above it. If the graph would have done this, for example, if I wanted to know that one, we'd be approaching from either side, and we would not be able to have this argument about is it from the left, is it from the right, below or above, difficult for me to say. We wouldn't be able to have that conversation. But what we're really dealing with is approaching 0, an x value of 0, and in the process of doing so, we get a y value of 2 for our limit, and we approached that 2 by coming up from underneath it. So what we really have is the limit as x approaches 2 from numbers less than 2 for f of x. And it's not this f of x anymore, it's now that. So as we approach 2 from the left, the y value is 0. There we go. All right, last problem on this page. If f of x equals 1 over x, what is the limit as x approaches 0 of f of x? So what we really need to do is find that. Okay, this is f of x. Can we plug a 0 in? No. Well, can we figure it out based on the graph? Actually, no. This is the value, this is the graph of 1 over x, right here. And so as we approach an x value of 0 from the left and from the right, we don't consistently approach the same value. We definitely don't come from the same side like we did here or like we did here. We're going towards infinity here, negative infinity here. So already this inside part does not exist. So this limit does not exist.